going to have a look at Theorem 11. So this is if three parallel lines cut equal segments off some transversal line, they'll cut equal segments off any other. So that doesn't mean a whole lot. So we draw a diagram to see what's going on. So we have three parallel lines. So we'll follow what's in the book, what you might be having a look at. So we call them L, M and N. So they're parallel lines, and they cut equal segments off some transversal line. So a transversal line is a line that goes across parallel lines, so that would be a transversal line. So we're told that they cut equal segments off, so we're told that that and that are the same. So we'll label this point A, this point B and this point C. So AB is the same as BC. So they cut equal segments off some transversal. It says they'll cut equal segments off any other transversal, so we draw another transversal line. So over here we call this one K, and we want to show that if this is, we say, D, E and F, we want to show that DE is the same as EF. So that's the plan. Right, we'll write down first of all what we're given. So we're given three parallel lines, L, M and N. We're given a transversal, T, which cuts them at A, B and C respectively. Respectively just means in the same order. So it cuts L at A, it cuts M at B and it cuts N at C. So this cuts them at A, B and C respectively. And we have a transversal, so another one, a transversal K, cuts them at, so D, E and F respectively. And the last thing that we're told is that this is the same as this, so AB equals BC. So we have straight lines down to mean the length or the distance from A to B is equal to the length from B to C, so the distance there. Right, so that's what we're given. So the next thing we have to do is write down what we're like to prove. So to prove, so come back to the picture, and everything, it always comes back to the picture. What we want to prove is that DE equals EF. So that's all we write down. To prove the distance DE equals the distance EF. Grant. The next step is the most important in any of the proofs, so it's the construction. And this is where the kind of key idea comes in. So if we go back to the picture, what we're going to do is we're going to draw a line through E that's parallel to this line over here. So roughly parallel would look something like that. Kind of parallel will do. We'll call this, say we call this P and this Q. And what we want to do is we want to show that this triangle here is congruent to this triangle here. And if we can show that these triangles are congruent, then that means that DE has to be the same as EF. So that's the plan. There's two stages. The first stage is showing that this side, PE, is the same as EQ. And the way we do that is we're going to use these parallelograms over here. So what we're going to do is we're going to say, well, that's a parallelogram. These two are parallel, and these two are parallel. So that means that PE is the same as AB. In the same way, this is a parallelogram down here. So that means that EQ is the same as BC. But now, because AB is the same as BC, that means PE is the same as EQ. Alright, so that'll give us this side and this side match. Then it's very straightforward to show that the angle here is the same as the angle here, because they're vertically opposite. And the angle here at P is the same as the angle here at Q, because they're alternate angles. That's a line that's parallel to that one. The red line is cutting them, so this angle and this angle are alternate angles. And then we're finished, because by angle, side, angle, this triangle and this triangle are the same. So it's now just kind of a matter of writing that down and getting kind of the notation in that right. So we'll start off by saying that this is a parallelogram, so this equals this. This is a parallelogram, so this equals this. Because the two of these are the same, that means that the two of these must be the same. Right. So, sorry, the construction, which we better describe that first of all. So the construction is draw a line through E parallel to T, and this cuts L at P, and it cuts N at Q. So that's just labeling the P and the Q that we have in the diagram. Okay, so that's the construction. So now the proof. The first thing we said was that PABE is a parallelogram. So the distance PE is equal to the distance AB, and the reason is opposite sides of a parallelogram are equal. Okay, so you have to give the reason, so that's the reason there that we give. Opposite sides of the parallelogram are equal. Similarly, so that's kind of the first thing we do. Second thing we do is we say similarly, EQ is equal to BC. And it's similar because it's the exact same setup. See, so PABE is a parallelogram, so this side equals this side, and EBCQ is a parallelogram, so this side equals this side. Okay, so now the next thing we do, as we said, is that AB is equal to BC, and that's given because we were told it in the statement of the theorem. We were given that. Therefore, EQ equals PE. Okay, so that's kind of the first half of the proof. We've shown that the two sides are equal. The second thing that we do now is we kind of turn our attention and think about the triangles explicitly. So in the triangle, we have DPE, and so it's important now just to say that we get the order of the points right. So you get DPE, the D corresponds to the F, the green line there, the P corresponds to the Q, and the E stays the same. So DPE and FQE. Alright, so FQE. So the first thing is EQ equals PE. We just showed that, so there's no real need to say anything more about that. So that's the side. The second thing that we have is we said that DEP, so this is going to be the size of, this is the angle, DEP is the size of the angle FEQ, and the reason for that is that they are vertically opposite. Okay, so vertically opposite, so then that means that this is an angle. And finally, we have that DPE is equal to EQF because they are alternate angles. So that's an angle. So all we have left to say is therefore by angle side angle the two triangles are congruent, so DE equals EF. So that's all. So the very last thing that we write is therefore the triangle DPE equals the triangle FQE, and again just make sure you have the order of the points right. By ASA, therefore the side DE is equal to the side EF, and we're finished.